All right, this is section 12.1. It's not very tough of a section. Let's go through it. This deals with sampling, frequency distributions, and graphs. And so we kind of move into an area where it is more related to statistics. This is a very light introduction into statistics, which is 12.1 through 12.4. We're just going to do 12.1 today. Let's take a look at this. It says a government or the government of a large city needs to determine whether the city's residents will support the repair of several roads. The government decides to conduct a survey of a sample of the city's residents. Which of the following procedures would be the most appropriate for obtaining a sample of the city's residents? Now, you can sample things many different ways. You can sample things with minimal bias or sample groups with lots of bias. You can get an answer for whatever you want pretty much. Depending on your sample, that's going to impact your view or the general outlook on this particular project. So for example, let's take a look at this. Survey a random sample of the residents who use public transportation. This is not the ideal way because it doesn't take into account the people who don't use public transportation. So obviously, for these people, it might create a bias because what we're looking to do is figure out if they support repair of roads. Well, these residents who use public transportation, they may not drive as much. So maybe it's not as important to them. So they might be more likely to vote against it. Or the other way, they use public transportation, they realize they ride on roads, they might want it. What you want is a good sample. Anyway, survey every 5th person to enter the local church. Yeah, that's not the greatest idea. Survey the last 100 residents listed in the telephone directory. What, that's all your Z's? Do the Z's account for all the A through S, T, U, V, W, X, and Y? No. So the last one, survey a random sample of persons within each neighborhood. That makes the most sense, doesn't it? Because then you're going to get a good idea of what, in general, everybody wants. Okay, let's take a look at this next one. A questionnaire was given to students. The first question asked was, how stressed have you been in the last week on a scale of 0 to 10, with 0 being not stressed and 10 being as stressed as possible. The responses are shown at right. All right, so let's understand what's going on here. This is known as a frequency distribution, okay? On the left is always what you are kind of generally looking for. In this case, we're looking at stress ratings. On the right of it is always going to be your frequency. Frequency relates to how many people or things fall into that category that you're measuring. So for example, in this particular problem here, the survey asked to rate your stress rating from 0 to 10. And so this represents the number of, in this case, people who responded 0, 1, all the way to 10. In other words, at a stress rating of 5, right in between, they had 10 people report that. If we add up everything in the frequency column, we will find out how large the sample is. Isn't that true? This total here will tell you how many people were sampled when it comes to stress rating. Any questions about that at all? Okay, so now you understand what a frequency distribution looks like. Let's answer the question, which stress rating describes the greatest number of students? Which one is that?
8.
8, exactly. The 8 is the stress rating that represents the most because it has the greatest frequency, naturally, okay? How many students responded with this rating? How many? 31. It's that easy, done. Okay? That's all there is to it, simple. Now, normally, a frequency distribution wouldn't just be handed to you, right? Normally, you have a set of data points. And that's what's happening in this next problem is that you need to create your own frequency distribution based on a set of data points. In this case, a random sample of 30 college students. Stop right there real quick. How many numbers should be here real quick? 30. Okay, good. Each student is asked about how much time he or she spent on homework during the previous week. The following times are reported. So here are all 30 respondents' reportings of the time they spent on the homework in the previous week. Now you create your own frequency distribution. So they happen to kind of help you out a little bit to tell you the first class. This is known as a class, by the way. The first class is for people who studied or worked on their homework for 15 hours. How many people did that? Take a look. How many people did that? Let's take a look. 3. Good. Nice job. Then the next class would be 16. How many people studied 16 hours? 1. Is it 3? Okay. How many people studied 17 hours? 1. And we could keep going, couldn't we? Now, when we're all done with this frequency distribution, what number should end our frequency distribution?
25.
Is it 25? Is that the highest one? Is there anything higher than 25? Doesn't look like it. So 25 would be the last class. And then of course it would have a number. If I add up the frequency column, what number should I get? 30. Does that make sense, guys? If you get more or less than 30, you made a mistake in counting your frequencies. That's a way to check your work. All right, I'm not going to go all the way through, but you guys get the idea, okay? Now, I said a moment ago that the area on the left of all frequency distributions is called a class, right? You don't always have to have a class that is just made up of one thing you're looking for. Like in the previous two problems, they were single-digit classes, right? Whereas here we have a range. You can have a range when it comes to classes as well. And doesn't that make sense? You don't want to, let's say that there are 39 items here. You don't want to go 5, 6, 7, 8, 9, 10, 11, 12. That may not be what you're looking for when it comes to classifying your data. Maybe it's sufficient to just get things in groups of, in this case, 5, right? Okay, so you can have classes that represent or cover a range of different individuals or items. Does that make sense? Okay. With that said, let's go answer some questions about this. A professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the following grouped frequency distribution. This is known as a group. Why is it a grouped frequency? Because you have more than just one. Does that make sense? Okay. Identify the lower limit of the second class. What's the second class? Which one is this? What's the second class from the top? 10 to 14, exactly. So this would be the second class, and you can guess the lower limit is what? What is it?
10.
10, exactly, good. There it is, bottom end. Okay, now, let's take a look at this next one, next problem. The same situation, same concept, same setup. What is the class width? What's the class width? Now, easy to say 5, 10, 11, 12, 13, 14, 15. Be careful when you do your class widths, subtract +1, because then you'll catch all both endpoints. Okay, so the class width is 6. Pay close attention to that. It's not just your straight up subtraction, but it's fine. It's easy to make that mistake. Now, let me ask you a question. What is the lower limit of the fourth class? 28. What is the upper limit of the fourth class? 33. You could be asked about upper limit as well. Okay, so there you go. Next. let's just take a look at this question. Same thing about social interactions, but different numbers possibly. How many students had at least 45 social interactions for the week? How many students had at least 45 social interactions? What is that? Are you that careful? It would be what? Everything here. At least 45 means that you start at this class and go down. So it's 8, 3, 0, 1. So it's what? 12, exactly. Okay? There you go. Now, let's take a look at this next problem. It says, the following are the ages at which a country's presidents were inaugurated. So we have a data set, right, of presidents' ages when they were inaugurated, and then they ask you to go create a grouped frequency distribution for this data. They created the classes for you. Does that make sense? They created the widths for you. It's not a big deal. Let's just answer a couple of these. What is the frequency for the 41 to 45 age group of presidents who were inaugurated? How many go here? Is it 4? Nope. Let's go back. 41 to 45. Is it 5? There you go, good. And you can do this for the rest of the table, right? I'm not going to do that. That's for you guys to do. It's not that tough. Okay, so let's move on. Okay, moving along here. Here's that stress frequency distribution, right? So just another scenario here. But this time what they do is they ask you to graph it, okay? And what a graph, when it comes to frequency distributions, they're known as histograms. So bar graphs are also known as frequency histograms. Okay, so it's a histogram. So if they ever ask for a histogram, in other words, they're asking for the bar graph that corresponds to your data set. Well, let's take a look here. We have 4 of them. Let's just go through the first 2 and see if either of these are good. Does this one work? Is the first option a good one? Yeah. It looks pretty good. Let's look. This is a scale of 10, so this is a 5. 0, 2, that looks good. 1, 5, 2, 1, a little lower than the one before. 3, 15, 4, 10, 5, 14, 6, 16, that looks pretty good. 7 is 32, a little over. 8 is 23, good. 9, 15, 10, 15, that matches pretty well. And notice, this second one is way far off compared to that one. So there's no way that's it. No way on this one, right? No way on this one, it's reversed. So it does look like the first choice is the one. Does that make sense, guys? Now, you can also do a frequency polygon to represent your data. You're essentially graphing the same stuff, but instead of using bars, what you're doing is you're plotting the peak of the bars and then connecting the tops. So if we come back to our first one with our histogram, if we were to draw a polygon with it, we would just plot the peaks of all of these instead of drawing a bar, and we would go and connect them. Does that make sense, guys? So that's the graph that we should go be looking for. Which one of those looks something like that? Which one of those looks something like that? C looks good because it closes down at 0. It starts at 0, ends at 0, and then everything else. So C does indeed look like it's very good. Yeah, I think C's good. Nope. Is it A? It's really close. Yeah, it's probably A. Yeah, there you go. We're very, very close. You guys gotta look super careful. So there you go. You got the idea. Now, same thing here, except it's a different scenario. So I'm gonna skip problem number 9. Different frequency distribution and different bar graph that you have to match it with. Now, just a quick note here is that they label the classes by letter. So that's how you know where they're at. Does that make sense? Okay, so when you go do number 9, now you know. Okay, let's take a look at this next one, shall we? It says, describe what is misleading in the visual display of data below. Okay, so it says this is the percentage of the world's computers in use by country. Country A, which is this part, is supposedly 29%, and all these others are their respective percentages. Okay, what's misleading about this? Is the chart too small? B, the title does not explain what is displayed? No. The percentages do not add up to 100? Yeah, that's it. Look at this. And furthermore, 29%, what does this red area look like on the chart? Close to 50. So the percentages are not correct. Does that make sense, everybody? Okay. All right, wonderful. Let's go on. All right. It says a questionnaire was given to students in introductory statistics class. One question asked, how stressed have you been? There we go. Another one of those in the last 2.5 weeks. So the students' responses are shown in the frequency distribution below. You have to actually click this box. But let's go look at the question first. How many students were involved in the study? Before we even look at this, what do we know we need to do to find out how many students were involved? Add up the frequency. We're not going to go and add them up because I know that you guys can add on your own. But there's the chart. You would add. Would you add the left column? No. That's your stress rating. It has nothing to do with your frequency necessarily. Your frequency tells you exactly how many people were in the study. So the stress rating is what's being measured or reported on. The frequency is how many people report each respective one. So anyways, you know how to do it. Add them all up. Okay, let's take a look at this one. A professor had students. Here's their social interactions again. Among the classes with the greatest frequency, which class has the least number of social interactions? Which one has the least number of social interactions? 90 to 94. Least number means go find the frequency that is the smallest in the table. Does that make sense, guys? So 90 to 94. Done. Wait, sorry, hold on. Oh, sorry. Which class has the lowest number of social interactions? Sorry, number, not frequency. That was my fault, right? So, my fault, I was looking at frequency. They didn't ask for which class has the lowest frequency. It asked which one is the lowest. So, sorry, that's 50 to 54, right? And so, the 50 to 54 category, pay attention so you don't make my mistake. Wait, what? Hold on. Which class has the least number of social interactions?
55 with the highest frequency.
Okay, this is a problem. You need to read the whole question. I need to read the whole question. Among the classes with the greatest frequency. There we go, right? Then which class? Bad. Okay, so let's go through that. So let's go to the first part. Among the classes with the greatest frequency. What is that?
The 15s.
Right here. The 15s. These have the greatest frequency of our table, right? Which class has the least number of social interactions? Well, there you go. 55 to 59. Tanner was calling it from the start. Thanks, buddy. So this is, of all of them, this is the lowest social interactions class. So it is 55 to 59 indeed. And there it is, done. All right, wonderful. Let's take a look at this next one. So this one relates to IQ scores, okay? And it says the frequency polygon, sure enough it's a polygon because it's connecting the tops of the data points or the frequencies instead of a bar graph, which is a histogram. Determine if the following statement is true or false according to the graph. The percentage of scores above 105, oh, there it is, 105. The percentage of scores above 105 is equal to the percentage of scores below. Is that true? There's 105. They're saying the number of scores above is equal to the number of scores below. Is that true? In other words, is the graph split perfectly in half? Yes, I would say so. Now your problem might be different. If they said the number of scores above 95 is equal to the number of scores below, it would be false. Okay, so this is indeed true. And let's keep going. Now, last topic of the day is stem and leaf. What is stem and leaf? Stem and leaf is just another way of classifying data. Okay? The way a stem and leaf display works is that, let me back up here. What you do is your first digit, reading left to right, the leftmost digit is your stem. Your leaf is the digits that come after it, or are the digits that come after it. So for example, for the number 66, the stem is the first 6, the leaf is the second 6. For the number 47, the stem is 4, the leaf is 7. For the number 34, the stem is 3, the leaf is 4. For the number 20, the stem is 2, the leaf is 0. Now, how do you put that into a chart? Very simple. You can classify all of these and order them by stem. So for example, we can classify all the numbers that have stems of 2 and leaves, and that'll make it a lot easier than writing them all out. So let's just go do the stems of 2 because that seems to be the lowest one. Let's go list them. So going through it, our first one with a stem of 2 is a 0. Everybody agree? That's the 20 right here, right? There's the 20. What's the next one? 25. What's the next one? 25. What's the next one? 28. And no more. Did anybody see any more that I missed? Okay, so how would you do that? 0, 5, 5, 8. Make sure I didn't make any mistakes, hopefully not. And there you go. Does that make sense, guys? Now, the question is, do they have to be in order from least to greatest? Not for this section. They'll take them out of order. But good etiquette and good organization, you probably should, especially if you're reporting data, right? If you're reporting data, isn't it better to help somebody read the data and they can go, okay, we had a 20, a 25, a 25, a 28. There are 4 numbers that are in the 20s. Look how easy it is to read this. There are 4 numbers that are in the 20s. And these are what they are. Okay, let's just go do one more. I'm not going to do them all. So, doing the 3s, we have what? Let's see here. 32. Nothing there. 39. 33. 38. 37. 30. 31. 39. 30. 34. A lot more. Did I miss any? Okay, so I'm going to put these out of order this time so that you can see they'll still take it even though it's not ideal. So 2, and correct me if I'm wrong, 9, 3, 8, 7, 5, 0, 1, 9, 0, not a dash, and 4. Is that correct?
There's no 5 after 7.
Is there no 5 after?
There should be 0.
Oh, yeah, you're totally right. Let's correct that. There you go. Thank you, appreciate it. Does that make sense? Okay, and you would do that for all of them. Everybody got that? Okay, so now you know how to do a stem and leaf display. And so this last one, let's take a look at it. They give you a data set, okay? and they say construct a grouped frequency distribution for this data, okay, showing the length in miles of 25 rivers. Use 5 classes that have the same width. Before we even get started, you have to select the correct starting table. Which one of these should we use to start? Which one of these should we use to start? And here's my hint. Use 5 classes that have the same width. Which one is it?
C.
It's C. I think it's C as well. This one jumps around, doesn't it? Not all the same. This one also jumps around, not all the same. So we would start with C, or we would select C, and then it's time to go find out how many numbers fall into this category, this class, and so on. Does that make sense, guys? Okay, that's it. That's all for 12.1. And next class we'll do 12.2.